This is the reduction of copper using the eQCM. These cords are attached to the computer. Tanya did this part, so if you need help, I would suggest asking her. We made sure that the eQCM and the potentiostat were both turned on, and we can tell that they're on with the lights. We then poured our copper analyte. This is a 10 millimolar copper sulfate and 1 molar sulfuric acid mixture into the cell, and we fill it up enough so that it's covering the quartz crystal and our electrodes will be fully submerged.
We then want to make sure all of our wiring is correct, so we'll plug in our working electrode, which is green, and working sense, which is blue, into their corresponding colors. The orange lead is the countersense, which doesn't need to be plugged into anything, and then the black is the ground, which also doesn't need to be plugged in but can be. This white one is our reference electrode, and red is counter electrode. So these we're going to connect to our reference and counter electrodes in our cell, and just make sure that those electrodes are fully in the solution but not touching the crystal. And we don't want the tops of our electrodes or the metal parts, the metal clips, to touch each other either.
We then want to go to the computer and open the Gamry resonator application. And if it's not letting you open, it's probably because the potentiostat or the Gamry aren't turned on. And for this experiment, we want to start in the QCM tab and we want to change the frequency width to 50,000 hertz under the settings, and then click single scan. And if your single scan looks really noisy and you can't see a signal, then I would adjust the amplitude and the dampening parameters. And I would also make sure that the center frequency is around 5 to 10 to the 6th. And your single scan should look like this. And then you're going to drag those green bars on the side close to the signal. And just hit single scan again to make sure you have a clean scan. And then you're going to hit run. And you want this blue line to track the scan line. Then you're going to go over to the potentiostat tab. And it should look like this, where your QCM scan is running at the top. And ignore that potentiostat data that was from a previous trial. But these should be the settings for that potentiostat for the CV. And then you're going to hit run. And your CV should start running. And the QCM data should drop at the top and look somewhat like this. If it doesn't look like this, the crystal could be put in the wrong orientation. So you want to make sure that the keyhole is facing to the left and the flat part is at the bottom. And then we're going to let it run for its cycles. And once it's done running, we're going to save it. And then you have to save the QCM data separately. So we're going to go to the QCM and save that. And then we're going to go to Gamry Analysis 2 and open up the file you want to analyze. And it should look like this, or this is the CV with copper. And then you're going to go to the frequency versus charge graph and use the mouse tool to highlight a single one of those cycles. So it once you click on both sides of the line, it should highlight that whole line. And then you're going to go to Common Tools and Linear Fit, and it should give you a slope, a line with a slope. And if you hover your mouse over um, that line, it should give you the slope, and you can go to the right and deselect the other lines. So you just get that slope line, and then it'll be easier to find the slope with your mouse. And then you can use this equation to find the calibration factor once you have the slope.